Next, we have a very important topic called as activation function. So activation function is a very important topic because it can be asked as an essay question or as a 3-mark question. Moreover, we are going to see that there are many types of activation functions, so they can also ask you specifically. So as we saw in the previous slides, the output y of a neuron is given by activation function f into sigma xi wi. So this is the weighted sum of input, and this can be a very large value. So in order to bring it down to a smaller value, what we apply is an activation function. So this f will bring it down between the values 0 and 1. So it is also called as a squashing function. So there are different types of activation function. The first one is called as identity function. Identity function means it's just a linear function where if you're giving an input x, you're going to get the same output as f of x. So your activation function will give you the same output for a given set of input. But this can be only used for inputs which are very small values. So similarly, this is the graph of the function. So this is x and this is f of x. So if it is linear, means this is how the graph will be given. That is, for a particular value of x, you will get the same value of f of x. Next, we have a binary step function. Binary step function means, imagine this is the graph and this is some value theta, which will be the threshold. So once the input x is greater than the threshold, then the output will be 1, and when the input x is less than the threshold, then output will be 0. So this is also called as a hard threshold function. That is, the threshold theta will define exactly what the output f of x is going to be. Similarly, you have a bipolar step function where the output is going to be of two values, 1 and -1. So all these are just some simple equations, and also you have to learn the graph. So you have to learn each one of them specifically. It's an essay question, or as I told you earlier, you can be also asked to write specifically about a particular activation function. So the graphs are given over here. You can learn the graph also. Next, we have the Culloch and Pitts neuron model, which is a model which was discovered years before in 1943 by two people, Culloch and Pitts. So the model that they have proposed is, you will have x1 to xn plus m input. So these are the input neurons, and you will be having a single output node or a single output neuron, and all the input neurons are connected to the output neuron via the weights w and -p. So there are certain set of weights which are positive, and these weights are called as excitatory weights. That is, it will help to fire the neuron y. Whereas there are some set of weights called as -p, which is having weights less than 0, and they are called as inhibitory, because they will try and bring down y to 0, that it will not help y to fire. So like what we have studied before, if the output is greater than a particular threshold, then the output it will fire, or if it is less than a threshold, then the neuron will not produce any output. So it ultimately depends upon the threshold that we are setting. And this Culloch and Pitts neuron does not have any particular training algorithm. You can use any one. And for absolute inhibition of the output, that is, if the neuron should not fire, then this is the condition for that, where theta is the threshold N is the number of neurons, W and P are the excitatory and the inhibitory weights. Also, if it must fire, then this is the condition where it has K or more excitatory inputs. So you need to study these two conditions like a formula and you have to write. So based on Culloch and Pitts, you will be asked to write a short note or you will be asked to write a 5 or 6 mark question. So you have to draw the diagram and then you have to write about it. Next we will study about a perceptron network. Perceptron means it is same as an artificial neuron. So perceptron network is same as artificial neural network, ANN. So this was, many scientists have actually come up with various representation of a neural network. It is the same. It actually represents the same neuron and how it can be connected from input to output and how the output can be generated and all related to weights. So first let us see. So some input is coming from a sensory unit, that is there will be so many sensors which are placed here and each sensor will send something and that is going to give an input to the associator unit. The associator unit is nothing but the input layer. That is we have x1 till xn, x1 to xn inputs. Now using weights, all the input unit is connected to the output, that is y1 till ym. So from y1 till ym we have m number of output nodes or m number of outputs we will get. So each will be generating either 1 or 0. Then as we saw earlier, all these outputs that are generated need not be correct. So how will we correct that? So we have something called as a target output. So we will compare this input with the target output and then we will get an error and this error can be fed back and this error will be fed back here to the weights and the weights can be adjusted so that finally this output and the target output will become the same. Next we will see the architecture of a single classification perceptron network. So it is the same like what we saw before. You will have a couple of inputs starting from 1 to n and also you will have the output y. Now in addition to that I have added another term called as B. B is also called as the bias. Bias means if you know what's meant by a biased coin. So if you want to bring about that output value to a certain, if you need to bias, it's not the actual value. You need to do some bias to that coin and you'll try to bring either heads or tail completely, right? So there is a more chance that it won't be a 50-50 chance for getting either head or tail. You'll be getting more chance for either a head or a tail. So it is not the proper probability, but you are trying to force the output to a particular value. So here also you can force the output to a particular value a little bit more using this bias term. So instead of having just sigma xi wi, you will be having another term b along with it. So this is how you will get y in. So this bias will help you to just go towards or force towards a particular value a bit more. That is, more probability will be towards getting +1 or more probability it will be getting towards -1 based on the value of the b that you are setting. Next is the perceptron training algorithm. You will be getting only a single output case. We are not considering multiple output or multiple neural network y at the output. We are just considering one output in order to understand what is actually happening. So we have been saying that we train, we change the weights, etc. So here, when the output is not equal to the target vector, how do we update the weight? We update the weight using this learning rule, perceptron learning rule, which we saw before. Wi new, that is the new weight, will be equal to the old weight plus alpha is the learning rate, t is the target vector and xi is the corresponding input. And also we saw a new term called as bias, which will help you to force the output to a particular value. That is got by, new value is got by old value plus learning rate into target vector. So this is how you will get bias. If y is equal to t, that is your output is equal to the target vector, that is this else condition, then you need not update the weight. So the weight updation rule will stop when y is equal to t. The new weight will be equal to the old weight, and also the new bias will be equal to the old bias. So this is actually acting like a stopping condition for our algorithm. So till this condition is reached, we will keep on training every neuron and every weight in the network. So this may take ages, it may take years, it may take it's generally done using a computer. It is not possible for humans to do it. It is a computer algorithm, so it is done by the computer. Still, it may take a couple of days in order to complete the actual training.